Welcome to ClickMyProject.com. Now we are going to discuss about the project extracting fetal ECG signals through a hybrid technique utilizing two wavelet based denoising algorithms. Now we are going to discuss about the abstract of the process. Due to the recent advances in the area of the deep learning method, has been demonstrated that the deep neural network can recognize the cardiac arrhythmias better than the cardiologist. Moreover, traditional feature extractions was considered as an integral part of the ECG patterns recognition. However, the recent findings have shown that the deep neural network can carry out the task of the feature extraction directly from the data itself. In this process, we have three major steps like feature extraction, classification, and finally performance. So after doing the feature extraction, then the identification and classification of the ECG pattern is done by using the machine learning purposes. It is demonstrated that feature maps land in the deep learning that is trained by using the deep neural networks by using the input that can be generated as a descriptor for the ECG signals spectrograms and results in features that enables the classification of the arrhythmias. After doing the classification everything, the performance will be evaluated based on the accuracy and the error rate. Hence the accuracy of the classification will be improved in terms of improve the performance of the overall process. Now we are going to discuss about the flow diagram of the process. This is the overall working flow of this project. This project consists the modules such as input signal, pre-processing, feature extraction, feature matching, then finally performance estimation. These are the 5 modules consist in this project. At first, the input signal is taken from the dataset. The dataset consists of both the normal as well as the abnormal signals. After taking any one signal from the dataset, the pre-processing will be carried out. In this pre-processing, we have two kinds of pre-processing stages will be there. One is the noise filtering, then the second one is the normalization. In case of the length of the signal is too much of high, in the sense the signal length will be limited by using the normalization method. Filtering is used to remove the noisy peaks present in the signals. In case of any other additional noises present in the signal, it will be removed during the filtering method. After doing the pre-processing, the feature extraction will be carried out. In this feature extraction, we have a lot of kinds of feature extractions like QRS deductions. Then after that, the deep neural network is used to extract the feature from the signal. After doing the feature extraction, the test feature will be generated. Then the feature matching is done by including the test features along with the train feature and label. After importing these 3 data into one feature matching, that is nothing but the classification. We just doing the classification by using the machine learning algorithm. Hence the machine learning classifies the data. The performance will be evaluated by using the accuracy, sensitivity and the specificity. By using these 3 parameters, we can justify our process is efficient. So the classification result shows whether the signal is normal or abnormal. Now we are going to discuss about the initial running procedure of the process. At first, open the MATLAB 2019b and then change directory. If you want to execute the process, just right click in the main_GUI.m and select the option run. Once you selected the option run, the new user interface will be open in this window. Now the user interface was open. You can see the lot of push buttons in the right side for the controlling actions, then the lot of axis and table in the left side for the display purpose. First of all, we have to click this button input signal. So after clicking the button input signal, the dataset will be open. In that dataset, you can see the lot of dataset signals will be there. So we have to select any one signal from the dataset. After the selection of the signal from the dataset, the particular signal will be placed in the axis 1 with the title of ECG signal. After doing the selection, we just move to the second stage of the project, that is the pre-processing. So in this pre-processing, the pre-processed signal is shown in the axis 2 with the size with the title of pre-processed signal. Here, in case of any noises is present in this signal, it will be removed by using this filtering method. After doing the pre-processing, we just do the feature extraction. that is nothing but the extracting the data from the signals. Now you can see the results of the feature extraction. Now the PQRST waves will be calculated. Those peaks will be marked here. So you can see the difference between the input signal and then the feature extracted signal. So feature will be extracted, so peak will be detected here. After detecting the each and every peaks, those values are represented here in the table as a test features. So after extracting the test feature, along with that test feature we have included the convolutional neural network feature also to extract the efficient feature from the signal. After doing this feature extraction, the classification will be carried out. In this classification, the train features will be imported, then the classification results will be displayed here. After doing the classification everything, the final stage of the project is performance estimation. So we have to evaluate the performance estimation by means of the accuracy, sensitivity and specificity. So the value of accuracy, sensitivity and specificity for proposed thing is displayed here, and then the existing one is displayed here.